You got a microphone, you've got the voice there.
I got the floor. We have to be out here by 9:30 or 9.
Yeah.
Okay, let's move it. Well, ladies and gentlemen, I think we have about 20 minutes before we have to start thinking of packing up. All right. Well, some time ago, can't remember exactly when, thought of making a presentation on the Lecher wire was considered. I remember seeing a Lecher wire back in the late 60s when I was in an electronics lab when I was attending a JC at Riverside, California, but I never did see it demonstrated. I got in conversation with Chuck on the air, W6FT, no, W6, yeah, FT. And Chuck had in his archives a copy of a Lecher wire, and you're seeing that structure. Anyways, I kind of looked at it and thought, boy, that's a lot of work. In fact, it was almost a year ago I was thinking about doing a presentation, and I thought, man, that's just too much work to do. So, a couple of weeks ago, I got together with one of my other amateur friends, and we constructed a rather scaled down version of that. We didn't really want to sink, I didn't want to sink that much money into it until I knew what it was going to do. So anyways, what is a Lecher wire? Well, a physicist, a German physicist named Ernest Lecher, back in 1890, came up with it as two parallel wires used to demonstrate electromagnetic wavelengths, where RF is fed into one end of the wires and a sensing device is at the other end. There is a shorting bar that's rolled down, and you're observing your meter readings on the sensing device at the other end. If the Lecher wire is longer than a wavelength, you will find two nulls that will be indicated by the sensing meter. And this is a shameless copy from an article found on the ARRL website. And it shows a pickup in at the left and showing you the shorting bar positions at two places and a meter connection at the far right side. With the RF, and you do you look for these two nodes and you mark the spots and you measure the distance between the two spots, you will find 1/2 wavelength of the wave or the frequency that you are measuring. If this happens to be several wavelengths, you will find multiple wavelengths or nulls showing up. Well, we'll try to make a demonstration today. All I have is a yardstick in inches, and we need to convert the inches into meters. If you're an engineer, it's drilled into your brain that 2.54 centimeters equals 1 inch. So that's a little bit of mathematics. If I had a meter stick, then I could have done a direct measurement. Okay, one thing that bothered me, and everything was kind of set up until last week. The nulls never fully nulled. They were always up a little higher, never got to the bottom. And that kind of bothered me. And last week I started doing some additional research, and I came across an article written by Eric Nicholson, KL7HA, who I have not contacted yet, but will. And he described a Lecher wire a little differently. And he put a lot more information into it that got my attention big time. Eric talked about not only measuring the frequency, but finding out the characteristic impedance of the line that he was dealing with, and also measuring VSWR. Now you might wonder, how's this going to affect us? Well, several years ago, I took some surveys of the club, and their interests were in transmission lines. The highest interest was in transmission lines and antennas. If you look at the two parallel lines, does that remind you of something? Maybe ladder line? Okay, reading back through Eric's article, there was a comment at the bottom that really caught my attention. And he said the neatest demonstration of a Lecher line was a fellow took an HO railroad tracks, and he mounted the sensing device on a little wheel thing, and he rolled it to see the different modes. Well, I just described my unit as, or the one I've got out here front, as monitoring the current at the far right-hand side and moving a shorting bar. And Eric's is talking about having the sensor on the actual shorting bar, the bar he's moving. So in other words, it's not a shorting bar, it's just the meter or your sensing device is now being drugged and connected to across the two lines. Well, I was really excited about that, but unfortunately, I haven't been able to get it to work. I did have the help of Kim, KJ6RMN, who is a little better at making connections to HO wheels. And you can take a look up at that. I was kind of dumbfounded trying to find a way of doing it. But anyways, it's important that I probably get Eric's system to work, because I'm very interested in learning about SWR. If you're looking at, you end up with some highs, and what Eric does is you measure the high and you get the relative low value, and that gives you the ratio of your SWR. The impedance was when he was describing where you find the resistance of your two wires. And a Lecher line is roughly 33 ohms, or 100 or 333 ohms. And he was describing a way where you could experiment. And if you do find a perfect match, then these variations that you see on the Lecher line disappear. It's all one voltage. And that's with a transmission line, that's what you want. That load resistor being placed at the end would be actually your antenna. So, we're ready to do the first experiment, and I'm at a loss trying to get the last one to work. And since I'm trying to make this a hands-on type project, if people want to toss in their ideas, then please feel free to speak out. Let me show you how these things work. Okay, I need to cut this. I'm off. Okay, great. Well, this is going to be a hands-on. You guys can't see that, and there was no way for me to mount this thing up at a level. So we try to stand around and see how far this one goes. Probably kill the projector.
Kill a projector.
Okay, what things I have learned so far?
Would a metric tape measure help you, Andy?
That would be perfect. There would be no
We
conversion.
got one right out here.
You do. It's not metal.
Yes, it is.
Okay.
See, now that's going to kill the whole thing, huh? Gotta have a wood.
Yeah.
All right, he's got it.
Phone converter, so you tell me what you need.
Okay. Actually doing this experiment, there's lots of things that come to attention. First of all, as I said, we have two parallel lines. That sure looks like ladder line. One of our members, Jason, when you bring metal next to two parallel lines, it shouldn't have any effect, but it may. Jason ran his transmission lines behind a gutter, and I can't explain that. That's one thing, you can't run a transmission line or a ladder line through a house that has chicken wire. That's what do you call it?
Stucco.
Stucco. And that's why we came up, well, the Navy needed something back in World War II, and that's where we came up with coax, because lateral line couldn't go through it. They had to use coax, and it doesn't matter in that part. So, what I have for my RF source is a kind of a peanut whistle. This is a ICOM 7A, and it puts out about 700 milliwatts on 2 meters. I've got it set to 147.48. That's a simplex frequency. At the end, I have a 100 milliamp meter, and it has a diode in the circuit. If I was being a real stickler to protocol or circuitry, I have got some pretty long wires hanging off for connecting that meter. But we're just trying to get some sort of feel what this is going to do. Well, I'm going to have somebody come in and key my transmitter. And I'll stand here. Go ahead and just hit the mic. Just hold it down. And we'll have to pull away just a little bit. Got my meter pin. Let's see. Let me move it there. Okay, just hold. Okay. Okay. Let me start this shorting bar down here. And as I move this, I'm looking for a null. Well, Murphy was an optimist, wasn't he? Okay. That's not much of one, but let me mark that one.
It's null but not void.
Yeah, that's kind of it, Paul. So anyways, I'm looking for another.
There you go.
Yeah, that's a good no.
That's a good one right there.
Well, that doesn't look quite right.
There's the dirty wires.
For some reason, this first one doesn't seem quite right.
There you go.
That's the one. Okay. Okay. I've got this one to mark this spot. And I have about 36 inches.
I know, he said he was playing with that color.
2.5.
I just moved one of my meter.
Yeah.
Okay, let me just move this one down.
Gotta key the mic again.
Yeah, I'm doing it.
And I have about 33, 36, 37, 30, about 38 inches.
That's about right.
Okay.
There it is.
I do know from my initial experiment that let's see, Andy, you have to 2.54, then times it by or divide it by 100. And then multiply it by 2.
I was using a converter.
Oh, okay. You have 38 inches. Convert it to meters.
30 inches to meters?
Mhm.
So that's a half wavelength, about 1 meter. Makes sense.
No, it's about 2 meters. That is 1 meter, but this is a half wavelength. So to find out a full wavelength, you double it.
Right.
And that's
I
2.
mean, that
So
is
you
1
want me-
meter.
You want me to convert 38
1 meter
inches,
approximately.
38 inches to meters.
Yep.
.9652.
Okay,
About
and then
1
double it.
About
We're trying to find the wavelength.
All right.
And if you run that through, I'm sure everyone still remembers that the wavelength divided into 300 is equal to the frequency. That was on your exam. Everyone remember that one on your exam?
A long time
Okay.
ago, far, far away.
Okay, the important part to look at this is that we talk about radio waves and we don't have, we have frequency counters and receivers and I just believe whatever it's telling me.
Yeah.
But now you have a device here that's actually electrically or physically measuring what the wavelength is. Okay, from my work with these last week, Lecher lines don't come in one flavor, as I found out. As I said, the gentleman's, or Eric Nolan's, or Nichols, Eric's idea was, the newest one he saw was to get a hold of a HO set. And this looks to be like it would be rather convenient. I mean, where are you going to store something like this? And something like this could be easily put up in your closet. In fact, this is where this one was for the last 3 decades.
Yeah.
His description was to mount the sensor on it, not like the shorting bar, but the sensor, and then to move this along and look for the highs and the lows. Okay. I was having some troubles trying to figure out how these wheels on this HO set are insulated. So I need some way to tap onto the wheels. And anyways, Ken came up with a nifty idea, except the only problem I ran in after that was, where do I mount the meter? Anyways, I was having lots of trouble, and I wish to give this one try, and just to see how it happens, or what will happen, because I have assistants instead of myself working with it. These are 36 inches long.
Attach here.
Let me set this.
Hell to grow old and can't see.
Yeah. Paul, you may have told me that a couple of years ago, and I kind of sneered at you, but right now I know what you're talking about. They will no longer sneer at you.
Understanding comes with age.
Yeah.
Yep.
Should be readily available.
They used to be,
No. When?
70 years ago.
Talks on those connections there, so there's a good connection.
You know, I was, Andy did bring up a good point. And there's another point, it's like, what's these tables made of?
Cable together.
You got metal edges.
Yeah, the metal edges.
Oh, yeah.
Okay,
First test.
we're gonna give this a shot. As I said, I have not been successful at home. But this is our pickup loop. This is our pickup loop. The other end we're leaving off, Andy. We're gonna leave it open-ended.
No, but I did.
Oh, I see, you got two rolls.
The objective here is to see if I can't get that complete null. And as of this morning, I wasn't getting anything. Of course, I was trying to do this all by myself. I did find a cargo container to follow along, but the construction of that one was pretty cheap, and the wheels kind of fell off. So, key the transmitter up, and let's see if I can't get some sort of reading.
Somebody to walk along with the meter.
Ooh.
Okay. This is... Well, I need to see this go up to say if it's valid. Nope, I'm not happy with that result. Okay, something is, if all you can see is that the meter is not, I expect it to be up high as I'm looking at the waveform, and then to drop down and go back up. And that it's not doing. Okay, closing thoughts. The Lecher line is a good tool for exploring wavelengths. Also looking at SWR and looking at the characteristic impedance of a transmission line. Now, something struck me is from some conversations, not conversations, but some classes or seminars held at Pacificon, is that if you have a halfway and you're transmitting a frequency and you have this as a stub, imagine that hanging down, that looks like a short or a radio wave. This looks like a good tool for investigating shorts and stubs. Something that you can actually physically see and see the changes. I hope to maybe later on at another meeting come back and readdress this one issue. Thank you.
So, are you going to do the meters, another session?
Yep.
Okay, identify meters for a future meeting. This is great. Thank you very much.
You're welcome.
That's pretty simple.
Don't go anywhere. We still have our raffle.
Trying to do it simple. I know. No, that's great. See, stuff.
We may keep it.
Light bulb. And if I can find